Hello everybody and welcome back to yet another classic arcade repair. Today I just got out onto the bench a Midway 8080 Space Encounters set. And first glance I can see that this thing has 2716s and they did send along the original ROMs. But it looks like they changed 2716s and it looks like there's some strapping stuff here. We'll have to look at that and make sure that that's right. First glance, I don't think so. We'll see though. Yeah, so let's go ahead and set up the camera and everything, and I'll just start kind of poking around on this thing. And first thing I want to do is verify that this is set up for 2716s. I don't think it is, but yeah, let's look into that. Okay, we're going to go with that. So I will get the magic beeper tool, set it to continuity, and I want to grab -5 here and make sure it's not on this chip. Okay, let's grab 12. Okay. And 5 volts should be right here. Okay. So the power looks good. This is 5 volts probably. Yes. Okay. So it looks like that is jumped right. Okay. Address bit 10 is one of these. Yeah, I'd have to look at the schematic to make sure if address bit 10 is hooked up right. I just don't know from memory where it's at, even on the chip. I can look that up really quick. Address bit 10 on a 2716 is pin 21, pin 19. Pin 19. So we got 13, 14, 15, 16, 17, 18, 19. And that's one of these lines over here somewhere. That's this. So that's going to go over to one of these 08 outputs right there. So I'm going to say that's good to go. I'm going to say this is okay. Now the next question is, are these programmed correctly? Is this actually the right program? Everything, the strapping seems to be okay. We got a good crystal here. We have our 8080. We can remove that. Damn. That's okay. No broken legs. That's good. We should replace this socket. I'm going to redo this. I do not like this. This is a 5 volt rail right here, and I don't like this little flimsy wire here. So I just kind of want to look at something here. 5-volt rails, both of these. Yeah, that's the 5-volt rail. This whole railing is the 5-volt rail, I believe. So if I go to continuity, 5-volt rail, and let's go to pin 14, which would be right here. Right here, pin 14, or VCC. Okay. Maybe that isn't. Oh, it's because I'm on the wrong pin. It is this pin right here. Yeah. So this whole thing right here is the 5-volt rail. That whole kind of plane, you know, copper dump they call it, whatever, you know. So this is going to be ground, and on the other side of the board is all the 5-volt. So this is actually built very well. How this is designed. One side is all 5-volt, the other side is all ground. Cool. So what I like to do with these, instead of this little wire right here, which I'm going to remove right now, I will show you what I like to do with these. I'm trying to figure out, how was this done? This had to have been put in here, but it looks like that's factory. Well, anyway, this is how I like doing this. Just open a little spot, maybe even right here would be better, right? Take your fat solder and just bridge it. And that right there is how I like to do that. That jumps your 5-volt rail to that pin. Yep, just like that. Huh. It's tough. I guess that's good enough light. Yeah, just like that. Then you can just kind of clean it up a little bit. Maybe. There we go. There you go. It's a lot better than that cheesy looking wire. Now just to double check, our 5 volts right there. Yeah. And then, yeah, so that's it. Okay. So I think first thing I'm going to do is I need to get some fluke information on space encounters, and I might have that. I might have that put away somewhere. I don't know exactly. But I'll check that out, and then I'm going to replace this socket so that I can utilize my fluke. And I'll put this thing all together, get my harness out, I know I've worked on a Space Encounters before, so I probably have the Fluke signature information. I already know all of the RAM tests and everything, but I need a decent socket. And I'm going to replace these caps because all of these electrolytics seem to go open. Not all of them, but I always seem to find open electrolytics on these boards. So I'm going to go ahead and replace those. You know what else I should do right off the get-go? Let's check and see if we have a ground to power rail short on any of the rails. Should diode test. Okay. That's good. 5 volt. Okay. This is 5 volts. That's fine. This is -5. And there's nothing showing, so that's fine. Ground, of course, is ground. And then 12 volts is right here. Okay, so we got no shorts. That's good. But in order to keep it that way, we also need to replace these two tantalum caps. These two guys are 12 volt rail filters, and they like to blow up. Anything that's on the higher voltage, they just don't do well. These little guys right here are all filtering -5, I believe, and they're fine. They never go bad. I have never seen one of these go bad. These, on the other hand, they like to blow up and flame out on the regular. So replace these two guys. Leave the other littler ones alone. They're fine. And a little maintenance, and then we'll hook it all up and see what we got. I'll be back. Okay, I got my maintenance done. I've replaced the caps. And as I was saying, some of these just love to go open. Here's one. Positive to the positive. Just make sure I got it hooked up right. And it is completely open. If this one was in the video, I don't know which one was which over here. These are the ones that were over here. But if it was in the video, there'd be no video. So I've seen this so many times. These caps always want to open up over here. So if you've got a Space Invaders game board set, an 8080 set, replace those caps pronto. And replace these ones, because these ones are the opposite. They go short. I just put electrolytics in here, 50 volt electrolytics, and you'll be fine. It's just filtering the 12 volt rail. That's all it's doing. So yeah. But yeah, there you go. And here we have another one that is completely open. Just kind of putting some pressure on this for it to have a good connection. Completely open. So 2 out of 4 of these caps were open. Was one of them in the video? I don't know. That would have been nice to have kept them separate, but I didn't. So, it's a 50-50 chance that one of them was in the video. Yeah, so that would have totally killed the video. Alright, moving on. Okay, I got it all put back together. And I got it hooked up and powered up, and this is what we get. Just a blank white screen. Nothing happening. But at least we got video. There's sync through there and stuff, so that's good. So we just have a dead set. So I think I will, what I want to do is I just kind of want to poke around a little bit, make sure I got clocking signals and all of that good stuff. And then it will be time for the fluke. So yeah, I'm just gonna go ahead and make sure we have activity and life on this thing. This doesn't look like a RAM issue. This thing is just dead. There's nothing going on. So I will hook up and start poking around. Okay, got the old trusty Logic probe, and I want you to be able to see it, so I turn the light off. I don't know if I can see. You know what? Let's just do this. I will kind of move the light about right there, and addressing. Well, that one's floating. That's high. That's floating. Ooh, that's flashing. There's life. Okay, okay, good. Low, good. High. Low. Flashing, good. This is very interesting, though. This one is floating. Oh, no, it's not. Now it's not floating. This thing's cheesy. I don't know about this thing, man. This thing's flat out cheesy, so I'm going to get a different probe really quick. This one just doesn't work very well. As I say, it's cheesy. So I do have this guy. I purchased this off Amazon, I don't know, earlier this year, I guess. This one right here. It's one of those loud, annoying, noisy ones. And we'll grab ground. We'll grab positive voltage, maybe. You know what I need to do? Am I even on the right thing? Is that even 5 volts? Let me check really quick. It is, but it's 4.4 volts. Turn it up. Goodness, I can't even get to that. 4.5. I can't hardly turn that. 4.6. We're getting there. 4.94. We'll go with that. That might have been why that thing was acting funny. Okay. TTL pulse. Why are you acting weird? Okay. We got life, but we got nothing going on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Reset is low, which is what it should be. Alright, so we do have life. Well, here's a broken chip. This chip is broke. Broke, but it seems to work. Okay, that all seems to check out. I don't see anything that doesn't look right. So I'm going to go ahead and get the fluke out and start with some RAM and ROM checks. Okay, I realized I had the reset signal hooked up incorrectly. It goes up here, not into the edge connector over here. So I hooked that up right, and now we get a little bit. We get a picture, but it is, as you can see, it's just some garbage. So I will get the fluke out, start doing some checks, and see if we can't get a little bit further with this. Alright, good morning. Just got out and was doing some fluke testing. I got my signatures over here. And what I've discovered is I was getting a bad reading on this guy. And I tried removing it from the socket, and the black part of the socket wanted to come right out with the chip. These sockets are no good. These are original sockets that need to be replaced. This thing will never be solid. It'll never be reliable. Man, couldn't think of the word. It'll never be reliable with these sockets. So yeah, after I resat this and messed with it, I got the correct reading. So the ROMs are all good. The sockets are bad. I verified I got 2 bad RAMs. And how I go about doing that, the Fluke is a great tool for certain types of RAMs. When you see, I got 2 red dots on this one and this one over here. If I do a RAM test, alright, I get 02 error. I can loop that, and then I can just take a RAM and jump over it until it clears. So if I just do this, and that clears that error. So I know that. Now I'll continue. I'll repeat the test. Now I'm getting a different one, and if I loop that, I come around and jump some, and I'm looking for a change. If I jump this one, it continuously does this. See that? It just continuously is okay, and then, you know, dying with the looping function. So I know that those two are bad, and I need to just stop, replace those two, and then continue my tests. I could actually go ahead and do a RAM short on, let's do 24 to 2FFF, and I get the same thing. So if I loop that, come over here and jump that, that'll clear that. So that one's cleared. Now let's just repeat, loop, jump. Yeah, unfortunately this will not stabilize, it just does this. So I can't really go forward, but I know this chip is bad. So I need to stop, replace those two RAMs. I need to do all of these sockets and then go from there, put the fluke back on it, continue my RAM checks until the RAM are all working properly. So I'll go ahead and do that. I'm just going to cut these RAM right out of the board. I'm not going to bother desoldering them. I'm going to cut them out, pick the pins out, put sockets in, and put these two RAMs in. Replace all of these sockets, and I'll be back. I'll do all that off camera. Yeah, and it's just more proof of how bad these sockets are. Remember when I was probing at the beginning of this repair with my logic probe, and this one was coming up floating until it wasn't. Yeah, these sockets are just terrible, and they need to go. So, and as I removed all of these chips, the black tops of the sockets came right off with them all, every one of them. So yeah, we'll go ahead and replace all of these two chips, and we'll see where we're at. Okay, we're done and cleaned up. Got the two sockets replaced here, and I'm not even sure which one is the socket. Maybe that one, and that one right here, and then all of these good and cleaned up. And you got to use lacquer thinner. Do not use rubbing alcohol on these Midway boards. Lacquer thinner only. Notice I don't have any white residue junk all over the board. It's because I use lacquer thinner. Always use lacquer thinner to clean these boards. And look at how perfectly great this looks. So we have new sockets here, all here. Two sockets here for the two RAM. The new caps. And as Alex from Northridge Fix would say, better than factory. The only difference is this truly is better than factory, because Midway didn't use good sockets or very high quality capacitors for that matter. So this truly is better than factory. Shout out to Alex over at Northridge Fix. Okay, we're ready to pop the EPROMs back in. I'm going to put a couple new RAMs in here, and we'll do our fluke tests again and see where we're at. Okay, I checked all of the ROMs and they're fine. And now I'm running a RAM check on the whole thing, which is 2000 to 3FFF. And what this is doing is it's skipping. Now it's going to come down here. Nope, it's going back over this. Now it'll skip down maybe, yeah. And I think it's going to skip back up and do this again. If you see how it's coming back through? We have an addressing problem, I believe. I don't think this is supposed to work like this. I think it's supposed to go all the way down. I believe. I could be wrong. This might be okay. The RAM is not an issue anymore. Well, it did. It gave me a decoding error. I think we have an addressing issue. So yeah, I'm gonna have to look at these guys right here. I don't think our RAM is a problem anymore. I think it's the addressing. It's giving me a decoding error. So my guess is we have an issue with these 157s right here, these four 157s. So I will mess around with a little more fluke checks, writing and reading from certain locations and stuff like that, but I believe what I'm going to end up having to do is check these 157s. And here we can see I'm doing a RAM long on 2000 to 23FF, and that part of the address space is actually reserved for the CPU as program RAM, scratch RAM, work pad RAM, working RAM, whatever you want to call it. That should not be affecting the video screen. This is not video RAM. So we shouldn't be getting anything on this screen right now, and we are. It's actually affecting up here. So what's going on is we do have, I would suspect that address bit 10 is stuck. And it's causing it to jump to a different space in the addressing for the RAM. And it's moving to the video part of the RAM. So we're going to have a conflict between working RAM and video RAM. Okay, I know the higher of the bits start on the end, and then the lower bits are up here. So like bits 0 through 3 or whatever, 4 through 7, all the way down to the highest address bits, the most significant address bits. So I started on this chip, and I came to this mux, which is pins, 5 and 6 out to 7. And this is what I'm seeing pretty consistently. I've taken a bunch of snapshots of this. And if you can tell how a mux, if you know how a mux works, you'll know that this doesn't work correctly. Here we have the select line. Here we have the 0 input, and here we have the 1 input. Let me just make sure that is, yep, it's hooked up right. So we have selecting 0 at the start, 0 is low, okay, fine. Now it goes to selecting 1, and it's high for that duration. See, right here you have a high, you have a low. So, and it's alternating what it's selecting. So you're going to have an alternating output, high, low, high, and then it selects low, or it selects 0, which is a 0, then it selects 1, which is a 1, and that's fine. And it selects 0, which is a 1, it stays 1. And at this point it selects 1, 1 is a 0, and it stays high. Then it selects 0, which is high, it stays high. Now it's selecting 1 again. And 1 is a 0 right here. So we should have a 0. We should have a low pulse here. We should have a low pulse here. And we don't. That's the problem with this mux. Right here, same thing. These should be low pulses. Should have a low pulse right here. Should have 3 low pulses here. Yeah, and I can use the small scope when doing these because the enable is always low. So these are always enabled. So I only need 4 probes. I need to probe the select, the 0 input, the 1 input, and the output. If this mux was used in a circuit to where it wasn't always enabled, I could not use the little scope because I would need to probe also the enable line. But in this case, I can use the little scope and just verify and look at the waveforms, how this thing is supposed to be working. And I can tell that this isn't working right. We should have low pulses, and that is exactly, this is probably bit 10. If we look on the schematic, I bet you this is F7. It's F7. It is a 157. Pins 5 and 6 out to 7. I'll bet you this is address bit 10. I bet you. Remember the fluke was telling me that we had an address 10 decoding error? I bet you this is address bit 10. So, yeah, that would be my guess. All right, so let's look at the schematic. Let's find a schematic for this and look at this chip and see if that is indeed address bit 10. Okay, there's F7, and pin 7 is actually telling me that it is address bit 9. So address bit 9 is definitely no good. I should move over and check address bit 10. So let me go ahead and hook up to that and I'll check that out. Address bit 10 is actually pin 9, so it's 11 and 10 out to 9. So let's check that out. Okay, now address bit 10 on there looks absolutely fine. You can see over here, and I took multiple snapshots and really looked at this. You can see here where it selects 1 and 1 is a 0 and it goes 0. See how it didn't do before? It's doing here. Now the fluke might be saying that address bit 10 is giving it an issue, but this isn't actually address bit 10 as far as it's address bit 10 for these, but according to the fluke it's not address bit 10, if that makes any sense. It's a different address bit because it's being processed through these muxes and creating address bit 10 over here. So that bit obviously, according to the fluke, looks like address bit 10. So just kind of disregard that. Why is the fluke saying it's address bit 10 when it's actually address bit 9? According to the fluke side of the system, it's address bit 10, but on the RAM side, it's address bit 9, if that makes any sense. But the fluke was definitely telling us we had an addressing error, and we found the addressing error, so we'll replace that chip and we should be okay. Okay, now, and what I'm thinking is, remember that bit wouldn't drive low. You know, remember when it would select 1 and 1 would clearly be a 0 and it just wouldn't drive low to create a low pulse? Because of that, because it's not really stuck high, because that output would go low at times. It was just during a certain event that it wouldn't drive low. We should be able to jump a 157 over here and get this thing to work. Because this a 157 jumped over, it should drive that line low. Let's try that. Okay, I don't know if I'm, oh, look at that. Look at that. Now we have a perfect looking crosshatch. Interesting. Yeah, so that's obviously, I don't know what the dip switches are set to. I think the dip switches are set to crosshatch or something. So let me look into that and mess with the dip switches. You know what? I'm going to stop. I'm going to replace this chip. Watch this. I'll remove it. Well, now it's stuck here. If I stop it and restart it, yeah, it comes up goofy. Yeah, so let's go ahead, stop, replace this chip, and we hopefully will be good to go. Okay, I got that chip replaced, and I've got it switched on, and we've got a good crosshatch. So I bet that the dip switches are just set for this crosshatch. So I think what I'll do, I'll put the flute back on it, and we'll do our RAM checks again and make sure that the RAM is working correctly, and then go from there. Okay, this is a good sign so far. I'm doing a check on that RAM area that is reserved for the CPU as program RAM. And it said, okay, let's do it again. Let's go repeat. And you'll see it is no longer up into the video part of the RAM. Remember, it was messing with that top quarter of the screen last time. Yeah. So now I'll go ahead and do a RAM test on the video RAM. And it should go in uniform. Down, all the way down, and then back up and all the way down, and that's exactly what it's doing. So now we can tell that this is actually working correctly. Once it gets done here, it'll start back up at the top with another pattern and come all the way down. That's what it's supposed to do. See that? And that'll go all the way to the bottom. That's the video RAM. So this thing is now working correctly. Very well. So I'll let this continue through. I'm going to go do some research on the dip switches so that I can set the switches for this thing to run. And then we'll go from there. Okay, yes, our test is good. So our RAM is good. Our ROM is good. All that's good to go. I got dip switch information. And here it does say off on switches 5 and 6 for crosshatch. So we're going to turn those both on. I'm going to set it like this. Off for you do get a bonus. 3 and 4 on, 1 coin, 1 play. 5 and 6 on just for bonus. And 7 and 8 off and off for the time of play set at 90 seconds. So that's how I'm going to set it. So I'll be right back. Okay, I got the switches set over and the game is running, but it looks like it's got an error. You can see it's like really flashy and weird. And it is not supposed to be like that, I don't think. Yeah, it's like the corners are inverting or something. It's really strange. So there's definitely a playfield issue, and that's going to be on that daughter board. So we have issues. That is like epileptic seizures. Holy crap. I got to leave that. I can't look at that much. That's really bad. So yeah, we got a problem on this board for that. So I'm going to put my angle brackets on it so that I can flip this over. This board is good to go now. Now we got to look at that board. And you know what? That's going to be part 2 of this thing. I'm going to stop this video right here and now. And part 2 will be analyzing and troubleshooting that board.